Lesson 6. Finding the equation of an exponential function. Our goal this lesson will be to determine the equation of an exponential function given its graph. Last lesson, we learned that some transformations of exponential functions are equivalent. For example, given the parent function f of x equals 2 to the exponent x, a vertical stretch by a factor of 2 was equivalent to a horizontal translation by 1 unit to the left. Because exponential functions have this property, there may be many different but equivalent ways to determine the equation given the graph. The general protocol for doing this is described below. First off, in most cases, you will be told what the parent function is. This is important because it provides information on what the base is. After that, write the general equation of the transformation in the form g of x equals a multiplied by b to the exponent x plus k. Next, looking at the graph, you estimate the equation of the horizontal asymptote. Recall, this is the k value. You then substitute a nice point into the equation, and that will allow you to algebraically find the a value, and then write a therefore statement, and you're done. This protocol will be shown in the examples that follow. Example 1, we're going to find the equation of the transformation shown below, and the parent function is 2 to the exponent x. So let's get started. We'll just write out the general transformation. Looking at the graph, it appears like the horizontal asymptote is roughly at y equals 6. So we're going to plug in the k value as well as the base into the function. Okay, at this point, you have to find a nice point on the graph, and we'll substitute that into the function, which will ultimately allow us to find the a value. You're welcome to pick any point that you'd like. I'm going to pick this one. That's the y-intercept, and to me it looks like it's about 0, 5. This is where you likely will make mistakes because we're estimating from a graph, but as long as you choose a point that looks fairly clear and you follow through with your steps, you'll never be penalized if your point was a little bit off of what it really was. So we plug in this point, 5 becomes g of x, which recall is the y value. Plug in 0 for x. And now you solve for a. So 5 equals a multiplied by 2 to the exponent 0. Anything to the exponent 0 is 1. Five equals a plus 6. And solving for a, we subtract 6 from both sides, and that gives -1 equals a. And we're done. Write a therefore statement. And I just want you to ask yourself if it makes sense. We have an a value of -1. Recall, the parent function f of x equals 2 to the x should have a shape that looks something like this. That's the general shape of an exponential function with a base greater than 1. Look back at lesson 3 if you need a refresher. We have an a value of -1, so that's going to be a vertical flip or a vertical reflection, and that means the transformation should look something like this. And if you look at the graph, our graph does have that general shape. So that should give you some confidence that we've done it correctly. Let's move on to the next one. First of all, there was a small typo here. The parent function is 1/3 to the exponent x, not 3 to the exponent x. So please change that on your sheet. And let's continue using the protocol. So our job is to find the equation of the transformation shown below. Let's begin by writing out the general form. Looking at the graph, it appears like the k-value, or the horizontal asymptote, is about -2. So we're going to plug that in along with the base. And now we pick a nice point. I'm going to choose this one. It's the x-intercept, and it appears to be -4, 0. So I'm going to substitute that in. We replace g of x with 0. That's the y value, or the output. For x, I sub in -4. And now we solve for a. We have 1/3 to the exponent -4. That's a negative exponent, so I'm going to take the reciprocal of the base, which gives 3/1, or just 3, and that's to the exponent 4. We can bring the -2 to the left side, that becomes +2. And 3 to the exponent 4 is 81. Dividing both sides by 81, we get an a value of 2/81. Okay, let's write ourselves a therefore statement, and it looks like we're done. And once again, everyone, I just want you to ask yourself if it makes sense. In this case, we have a base that's a fraction, so the general shape of that is something like this. Our a value is positive, so we're not going to vertically reflect it, and the shape of our transformation has the general shape. So that should give you some confidence again that we've done it correctly. Moving on to our last example, we have a challenge one here. And the reason why this one is a challenge is because the base is unknown. So we're going to have two unknowns now, and you're going to see how this will play out. So I'll get started by writing out the general equation. Okay, looking at your graph, we have to estimate our k value. Here's -3. So it looks like the k value is roughly halfway between -2 and -3. So that's going to be about -2.5, or -5/2. Let's substitute that in. Alright, so what we have to do now is pick a point to sub in order to help us find a and b. We actually have two unknowns in this problem, so that means we're probably going to have to use 2 points. I'm going to use a little trick over here. Recognize that anything to the exponent 0 is 1. So if I pick my y-intercept, which looks like it's at 0, 2, watch what happens when we plug in that point. So let's substitute 0, comma 2. We replace g of x with 2, that's the y value. Replace x with 0, that's the x coordinate of the point. And look what happens. Anything to the exponent 0 is 1. There goes your base. Gone. Solve for a. Bring the negative 5 over 2 to the left side, so 2 plus 5 over 2 equals a. And evaluating that, we get an a value of 9 over 2. Let's rewrite the equation. Okay, we have one unknown now, and that's the base. Once again, you can pick any nice point you'd like for the base. I'm going to choose this one. This point appears to be 1, comma, negative 1, and I'd say that's a fairly nice point to work with. So let's plug that in. We replace g of x with negative 1, that's the y value or the output. Substitute 1 for the input value or x. And now we have one equation to solve for in terms of b. So we've got negative 1 equals 9 over 2 times b, because anything to the exponent 1 is itself. I'm going to do a little trick here. Notice we have a common denominator of 2 on the right side of the equation, so I'm going to multiply every term of the equation by 2 in order to cancel out the fraction. Doing so, we get negative 1 times 2, which is negative 2. Multiplying 9 over 2b by 2 gets rid of the denominator, just giving you 9 times b. And similarly, multiplying negative 5 over 2 by 2 gives you negative 5. And now we solve for b. Add 5 to both sides, you get negative 3 equals 9b. And dividing both sides by 9, we get that b is negative a third. Let's write ourselves a therefore statement. Sorry everyone, I just realized right now I made a mistake. And the mistake I made was right here. I'll just star it to be fully transparent. When I do negative 2 plus 5, I get positive 3. And then positive 3 over positive 9 is positive a third. And that should make sense because I did tell you that you should never have a negative base, and that's why I had to stop in the middle of this video to realize I made a mistake somewhere. So good, everything works out. So our base is positive a third. And we have a k value of negative 5 over 2. And that's done. That's how you would find two unknowns if you ever needed to. You're just going to have to use 2 points from the graph. All right, that's going to wrap up lesson number 6. You've been assigned a worksheet as some practice for homework. Try it out. If anything is unclear, just reach out. Take care, everyone. I'll see you in the next video.